Greetings. This video I'm going to assemble one of these boards and see if it works. This is the JAT801 and I'm not going to put all the parts on it because I need to reclaim them after I'm done. Like the supply bypass caps, I'm only going to put one on each side instead of, we got two here. And it should run okay, but I gotta desolder everything that I put on here, reclaim it. Just want to make sure it works. What we're going to do, we're going to redesign the board if it works. Just make a change here. We're going to make the transistors so you put them under the board and there'll be a hole in the board. You just screw them down right through the board. That way, it supports this end of the board and a smaller footprint. The board will be slightly larger, of course, but it's 10 centimeters by, I don't know, 8 or 9. It'll be 10 by 10 centimeters probably, just a little bigger. Smaller footprint, and you don't have to use standoffs on the side of the board because it's already fastened down via the transistors. So yeah, I'm going to do that. So what I like to start with is put all the low profile components on, the resistors, small caps, and kind of move up from there. I'm not going to put the coil on. This is a testing board, and the input low pass filter and the coil here on the output, and just take the signal right off here instead of from the speaker lead, since that won't be there. Run some step response tests, see if the amp's stable or not. That's probably the most important thing, and of course that it works. So I gotta do some basic matching of transistors here. These are the NE5551s, and I gotta find the, what are they, can't remember the number, 401 or something like that. Let's see, is this one of them? 5401, that's what it is. Where are my 5401s? BC337. Hopefully I can find some. Did I run out of those? I just spent 77 bucks on parts. I don't want to have to spend more. So let me look around here. Alright, I have baggy-ized them. So yeah, I have plenty. So good, I don't have to spend money there. And I'm going to use those other transistors I mentioned in the other video. That way it's, like I say, it's just a test. So, let me match up some transistors, see how they work. I'll speed match them. I'll just use the diode check on the meter and measure the base to emitter voltage, and if they match, I'll consider them matching pairs. I'll check them with this thing. I don't have a curve tracer or all that stuff, but as long as they're fairly closely matched, they're fine. Okay, I matched up some transistors. These are all 171. Those are the NPNs. These are the PNPs. They are 172, 173, so they're all pretty close. I don't think I need them all. I'm going to have to look at the schematic. But yeah, I checked the base emitter voltage, and they're all the same on these, and the gain is the same. Isn't that what influences the equations? The forward voltage of the base emitter junction and the temperature? So kind of a quick and dirty gain matching trick here. So I'm going to leave off the coil. I'm going to leave off one of these capacitors. I got two 220s. I'll just leave one off. I'll leave this out. This transistor Q10. I'll leave this out. These diodes are, these things are more protective parts. They do nothing in the circuit, normal operation. I'll leave this cap out. I have to leave the cap and the coil out to do step response tests because I need to find a, I need to feed it a sharp-edged 10 kilohertz square wave. And with these low-pass filters and the filter here on the output, it's going to kind of round those corners off, slow that square wave down a little bit. Of course, on this side, we'll leave off one of the capacitors. One of these capacitors will stay off. And it's probably about all I can leave off. The rest are critical to the circuit. I'm not going to solder a trimmer here. I'll just put a resistor in. Find what a good setting is for the bias and just pop a resistor in. That way I don't have to fumble with a trimmer on the board. I don't know. I'll see how it goes. Just something less I have to desolder. Okay. Let's get this thing going here. Okay, I have the resistors put on the board there. There's a couple like right there, that are not going to be populated. Like I said earlier. Larger ones will do later. But I have the color bands going all in the same direction. That will minimize distortion. Now if you're in the southern hemisphere, you put the bands in the other direction. That'll help the water swirl down the toilet in the proper direction. Okay, that was just a joke. I know somebody in the comment section is probably foaming right now, but just a joke, people. Oh, the background noise, the dryer's running. I have to do my laundry in my workbench areas back in this kind of half utility room, half computer room, half bench, third, I guess. Here's those transistulators. That's the smaller one I was talking about in the other video. 247, I think it is. TO264, that's what they should be designated. TO247, if I remember correctly, and TO3P. See, these are the same size, but these are a bit more massive. And I'm going to go ahead and use these. I soldered on some soldered on the legs here. That way these will fit on the board. These came out of an old car stereo amp I had like 30 plus years ago. A Pyramid. It was a Pyramid brand. 4-channel. I ran the thing bridged, two of the channels together. You're supposed to only go 8 ohms bridged, but I went 4, put a fan on it, and decided to stop working one day. I wonder why. But the outputs never blew. None of the outputs were damaged. It was, I think, an op amp or something gave up earlier in the circuit. So yeah, the output stage was fine. But anyway, I'm going to use these transistors. If you're newer to soldering up these boards, what you can do is do all of one value, then the next value. Like there's a lot of 220s on this board, and then I think there's some 10Ks. There's mainly 220s are the most most abundant resistors on the board. So I just did them all at once. But anyhow, good. The noisy dryer shut off. But yeah, just if you're kind of new to these boards with a lot of parts on them, it'll help you. You have to be careful with these blue resistors and the color codes on these 1%ers. You know, there's 4 bands instead of 3, plus the tolerance. So a 1K resistor, let's see if I can find one. Where are you, 1K? I think that's a 1K there. Yeah, that guy right there. Normally it's a brown, black, and red, right? Well, with these 4-bander, it's brown, black, black, brown. Then brown is the 1% tolerance. So you have to be mindful of that, or you'll end up putting a resistor in the wrong place or the wrong value. So, yeah, kind of watch out for that. Use your meter if you have to. But anyhow, I'm going to stop yakking and put some more parts on this thing. Okay, I have the board all soldered up except for the parts that I am not going to put on right now, like the paralleled output stage. If one pair doesn't work, there's no use putting the other one on until I figure out what the problem is. One little tip when you solder the outboard components here, what I do, I bend the pins up 90-degree angle, then I put the spacers under the corners here, then that'll set the level. So these will be at the same level when you solder these leads on to the board. It'll be at the same level. That one tilted. Right, you push on them so that they're flat, and then solder them up. But I think I have a problem already. These are in backwards. See the heat sink here? I put the label facing this way, so these, I'm going to have to go back and turn these around. So that should be a pain to get off the board. These double layer boards are a pain to desolder, but yep, I just noticed that. I got to turn those parts around. Once I do that, I should be ready to apply power, see what happens. Okay, it's party time. I hooked up power and a speaker. The nice thing about these amps, they run on low voltage. So I'm going to start at 2.5 volts plus or minus. Current limit set at 0.5 amp. Here goes nothing. I didn't hear anything from the speaker, though this amp should be pretty pop free at turn on. We are drawing a hefty amount of current. It's climbing. The reason for this, I don't have to mount it on a heat sink. Keep the voltage low, keep the current low, just to test it. Let's see, is the thing actually working though? If I touch the oh my God, it actually is doing something. It's actually acting like an amplifier so far. Now I can't set the bias because I soldered a resistor in, but I am running more current. in the voltage amplification stage. That might have thrown off. I just took one of my 501 boards and measured what I had that trimmer set, and popped in a value. Is that about 120 ohms, so I just soldered one. But since I'm running more current in the voltage amplification stage, that might need to be a different value. So let's see, do we have a problem? See, the current's up to almost half an amp now, and that's because these aren't thermally tied to this, so they're going to get hot. I could put a piece of copper or something on there. But anyway, let me monkey around here, see what's going on. I just noticed something. I had my headlight on here, and I was hearing this buzz when I moved it around the board. Hear that? So when I put it over this LED, it's causing it to change the current, I guess, enough in the differential input stage to cause that buzz. That's right. Yeah, LED is affected by light. Well, pretty much any silicon is when it's exposed. So yeah, that's kind of wild. But anyway, here's my predicament. For VR1, I put a 120 ohm resistor in, and the bias is way too high. Well, if I lower the bias, that's going to turn this transistor off more, or lower its conduction. And when that happens, the bias spreader voltage goes further apart, turning the output on higher, so you get more current in the output. But I can lower this value, which would counter that effect, turning this on more, and it should lower the bias. So let me play around there. Okay, I found R16, and I took this 2.2K resistor, and when I put it across there, I can do it here through the camera. Yeah, the bias current drops. Take it off, it's maxed out at the current limit of the supply. Connect it, it goes down. So, I guess I'm just going to desolder this and put a lower value in, maybe, I don't know, 100. I didn't want to use one of my trimmers on this board. It would be a bear to get off, to remove it, to reuse it. Like I said, I'm going to recover the parts from this board. Probably not the resistors, it's not worth it, but you know, these larger resistors, sure. All the other parts, but yeah, I don't want to use parts that I can't get off easily enough. It's a bear to get these, when I flip these around, because they were in backwards. Yep, they definitely were in backwards, but when I flipped them around, it's just a bear to desolder these things. But anyhow, let's try another resistor here and see what happens. Did I say go lower in the last segment? I meant that resistor, where the variable resistor is supposed to be in the biasing circuit, so the biasing setting, this resistor has to go higher. That will turn this on more. No. Yeah. Allow this to turn on more, collapsing the bias, reducing the current. Confused as I am? I think I got it. I might have to redesign this biasing circuit. But yeah, I still got to put the rest of the output stage in, since it's a paralleled output stage. So yeah, I don't know yet, but I might have to do some adjustments to these resistor values. Okay, let's play music. That's what this is all about. All this crap I have to go through just to make the signal bigger to drive a speaker, if you think about it. Isn't that kind of ridiculous? All this stuff you have to go through to make the signal bigger, to make the speaker cone move from the weak signal of the music player. Anyway, your turntable, your tape deck, your whatever. Anyway. Oh, I just ripped the board down. Whoops. I lost that love. Oh boy, might get me a copyright thingy. Let's try some YouTube safe music. But it works. This thing actually works. I did catch my mistake putting these in backwards, but I figured, oh, I'll probably not solder something, miss one of the terminals on a component, or put something wrong in, but I did it. I think I got all the parts in right. What would happen? Let's see, what is... See, I'm looking at this thing upside down. This is a rail, so the speaker will go pop. This is the bass. It's being driven by the driver. Okay, enough fun. The amp is working so far, but I'm going to put the rest of the output stage on, and then it's time to test it. Put it through its battery test for stability and all that good stuff. And maybe there'll be some changes, I don't know. But we'll respin the board. I'm going to put the transistors under the board and you mount them. I don't know if I mentioned that before in this video, but it's pretty cool. The JAT801 lives. Wrap it up here. Catch you later.